Spinning, spinning, spinning. Everything is spinning, spinning, spinning. Swirling, swirling, swirling. Everything is swirling, 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 swirling. Yup, that's me. And you're probably wondering what got into that guy. Drugs! But not all drugs have the same side effects. Some make you act like this. Others make you act like this. Swirling, swirling. Everything is swirling. But why? Well, it all has to do with the nervous system, and particularly how these drugs affect the individual neurons themselves. So the question is, how does a neuron normally function, and how is this function altered by exogenous substances?
Here we have a neuron, which is the cellular unit for the nervous system. In order to get things going, we're going to need a stimulus, which is normally the designated neurotransmitter, to activate the ion channels on the dendrites. So once these channels are activated, the positive charge from the outside of the cell comes to the inside, making the cell slightly less negative. And this creates an action potential at the axon hillock, which fires an impulse down the axon and is constantly reimbursed by cations at the nodes of Ranvier. So once the polarization reaches the axon terminals, it causes the release of neurotransmitters into the synaptic cleft, which is the space between the axon terminals of one neuron and the dendrites of another. And because the neuron does not release neurotransmitters perfectly, there are leftover neurotransmitters in the synaptic cleft, and they are sucked back into the cell that released them by mechanisms called reuptake pumps.
So now that we understand how that works, let's talk about drugs and explore the wonderful world of exogenous substances, where everything is a ligand, which is anything that can bind to a receptor. And these ligands are known as either agonists or antagonists. Agonists are ligands that bind to receptors and activate them, while antagonists are ligands that bind to receptors and do not activate them. Instead, they block the receptor, preventing other substances from connecting to the receptor.
The lock that represents a receptor and the masticator represents a neurotransmitter. The two easily fit into each other, and I'm able to get inside. It represents an agonist, but although I have a little trouble getting the key in, I eventually get inside. Every time I have a random key that represents an antagonist, and I struggle to get it inside the lock. But once I do, it's stuck, and I can't get inside, and no other key can get it. But not all agonists have an overall stimulating effect, and not all antagonists have an overall negative effect. What? Agonist morphine, which has inhibitory effects, and antagonist benzylmethylecinin, otherwise known as cocaine, has excitatory effects. But until next time.